Okay, today we are looking at a topic that you should be familiar with. However, you have slept quite a few times since this was last introduced to you. So, linear equations with two variables. There are two methods to solving systems this way. The first one is substitution. This means that I have isolated one of my variables and I'm going to plug it into my other equation. So I've got my two equations, and on this bottom one, if I wanted to isolate x, meaning x is by itself, I could just add 7y, and 7y minus 7 is now an expression of x in terms of y. So I can substitute this whole expression in place of x in my top equation. So 7y minus 7 plus 6y equals 19. So now I can just combine like terms. I can combine my y's and I get 13y. And if I move my constants to the other side, I'm going to be able to solve and get that y is equal to 2. Now that I have found y, I can plug this value into my solved equation for x to get the value of x. So x is going to be 7 times 2 minus 7. And then we found that x is 7. So we want to give these answers as an ordered pair, so x comma y. So 7 comma 2. That is our answer. X is 7, y is 2. Now the other way we can solve these is with elimination. By elimination, we are getting rid of one set of variables. And to do this, both of our equations need to be in standard form, meaning all of my variables are on one side with like terms combined, and all of my constants are on one side. So, with this first one, I could cancel my u's or my v's. You could cancel the u's or the v's. I'm going to cancel my u's, and I've got 2u and 3u. In order for these to cancel, they need to have the same coefficient, and one needs to be positive and one needs to be negative. So between 2u and 3u, my common multiple here is going to be 6. So to get that 2u to become 6, I need to multiply it by 3. And to get the 3u to be 6, I'm going to multiply it by 2. Then I have to switch the signs of just one of them. So you can do either one. I'm just going to go with the top. Again, you could make the 2 negative as well. It doesn't matter, but both cannot be negative. So I'm going to distribute this negative 3 to all three pieces of what's inside my equation. So that will give us negative 6u minus 9v equals negative 24. Then same thing with my 2. You multiply it by all three parts. So 6u plus 8v equals 26. And I'm now going to add my two equations together. So I'm going to combine everything on the left. Negative 6u and positive 6u cancels. Negative 9v plus 8v gives me negative v. And then everything on the right side, negative 24 plus 26 gives me positive 2. Now I want to get v by itself, so I need to get rid of that negative. So we'll divide by negative 1 on both sides, and v is 2. Now that I know what v is, I can solve for u by plugging this value of v back into one of my equations. I've got a couple different options here, but my advice to you is to plug it into one of your original equations because it's going to be smaller numbers, less room for error. So I'm just going to plug it into that first one. So 2u plus 3 times, v was negative 2. 2 divided by negative 1 is negative 2. 3 times negative 2 equals 8. And I'm going to solve that and get that u is 7. So again, ordered pair, we're going to put this alphabetically. So u will go first and v will go second.
Martin Warriors teacher.
That interruption. We're going to use this elimination method again on this second equation. So my x's, one is already positive and one is already negative. So I'm just going to make them both be 6x by multiplying the top equation by 3. So negative 6x plus 9y equals 27. And then my bottom equation, 6x minus 9y equals negative 27. So I'm going to combine everything on the right. Both my x's and my y's cancel, so that's going to leave me with 0. And then on the right, my 27 and negative 27 also cancels, and that leaves me with 0 as well. Now, 0 equals 0 is a true statement, so my answer is infinite solutions. And I apologize about that bell. So when you get a true statement, it's infinite solutions. Okay. Now this next one, would substitution or elimination be easier? Honestly, you could do either one. You have opposite signs with your x's and your y's, so you could use elimination, or your x's and y's are easily able to be isolated. I personally want to use elimination because I have already my opposite signs. So if this is 3 over 2x, in order for this one to cancel, it also needs to be 3 over 2x. So I'm going to multiply my bottom equation. So I get negative 3 over 2x. 3 over 2 times 2 over 3 actually just becomes 1 because those are reciprocals. So plus y equals negative 3 over 2. And my top equation stayed the same. So I'm going to add everything on the left. That cancels and that cancels. So I'm left with 0 equals. And then 4 minus 3 over 2 is actually going to leave me with 2.5. Now, 0 equals 2.5. This is a false statement. So my answer here is no solution. When I get a true statement, it's infinite solutions. When I get a false statement, it's no solution. So our system of equations are going to have either one solution, infinite solutions, or no solution. That is the 3 possible answers when solving a system. Then this last problem on the front, for what value of k does the system not have a solution? So remember, we don't have a solution when we get a false statement. So if everything on the left canceled and I was left with 0 equals a number, that would be no solution. So if I was going to try to use elimination to solve this problem, I could cancel my x's by multiplying the top equation by negative 2. So I'll get negative 4x plus 8y equals negative 6. And then this is my bottom equation. So already my x's are going to cancel, and I'm going to get negative 5 on the right. So what value of k here would make this y cancel and give me a value of 0? That would be if k was 8, because 8 and negative 8 would cancel to 0. Okay. On to the back side, and this is where you'll need your TI-84 if you don't already have that handy. We can solve these by hand, but there's also a way that we can solve these in the calculator. So the first step is that these equations need to be written in slope-intercept form, meaning you have to get y by itself. So if we rewrite this first equation by moving over my x's and then dividing everything by 4, we're going to get negative 1/2 x plus 2. And then I need to do the same thing for my second equation. And then divide everything by negative 3. And there are my 2 equations in slope-intercept form. So now on my calculator, I'm going to go to the y equals, which is on the top row, far left. And I'm going to plug in these 2, and I apologize, that should be negative 1/2. I'm going to plug in these 2 equations into my calculator. So remember, the negative is different from the minus. So it's negative 1/2, which is also 0.5. X, you get that value here, plus 2. There's my first equation. Then my second equation, 4 divided by 3, that doesn't turn out to a pretty decimal, so I have to leave it that way as a fraction, plus 2. So there are my 2 equations, and I'm ready to graph them. So along that top row, that graph button is going to plot them for me. And I can see that they intersect at one point on the graph. So I'm going to have one solution here. And I could try to eyeball it myself, or I can tell the calculator to figure out this intersection point for me. So second calc, I'm going to go to that intersect. And so you could either scroll down. Come on, focus. Focus. So you can either scroll down or you can just press the number 5, and then you're going to hit enter 3 times. And so our solution here is 0, 2. When x is 0 and y is 2, these two lines overlap on the graph. Okay? Now to save time, I'm going to go ahead, the second set of equations, when we rewrite it in slope-intercept form, we get x minus 9 for both of them. And when I plug this into my calculator, they're actually going to be the same line. They're going to overlap. I'm just going to have one line on my graph. So this is going to be infinite solutions. They touch everywhere. The next example, when I get these in slope-intercept form, I'm going to have x over 5 plus 3 and x over 5 minus 7 over 10. So when I plug both of these equations in, I get what appears to be lines that don't touch, but I can tell my calculator to double check, and I get an error message when it tries to calculate the intersection. That's because these lines don't touch anywhere, so that would be no solution. These are parallel lines, and therefore they don't ever touch. They have the same slope. Okay? Now I'm about to get cut off on the video, so I'm going to do the last two examples on a different video.